In this lecture, I'd like to talk you through how to determine the chronology of a stratigraphic section. So chronology just means putting the rock layers and any other events like a fault in chronological. Down at the bottom here you can see we have places to put the letters from oldest to youngest. So I have found in my own experience that it is easiest to begin with the first thing that happened in the area, which is the oldest thing. This is usually the layer of rock, that's at the bottom of the stratigraphic section. In this case, we have two layers that are at the bottom. We have layer A here in green, and we have this Pluton K. Both of them occur at the bottom. So we have to determine which one is actually the oldest layer. So the way that we would do that is to look at both layers and see if they are cutting across any other layers. Because the principle of cross-cutting tells us that if something cuts across something else, then it has to be younger than the layers that it cuts across. So if we look at the green layer, we can see that it exists kind of everywhere at the bottom, except for right here, right? It is certainly being cut by other things. This cuts it. This cuts it. These are dikes and volcanic pipes. This fault over here, J, cuts through the green layer. But there is no place where the green layer is cutting through something else. If we look at K, the Pluton, we see that first of all, it intersects with the green here, but it also appears to cut across this layer B, this layer C, D, E, and then it stops. It does not cut through layer F. So what that tells us is that K, the Pluton, must be younger than everything it cuts. So it has to be younger than layer E. That's the last layer it cuts through. Basically what we're saying is that all of these other layers, A, B, C, D, and E, had to have been there already, or they couldn't have been cut, right? They had to have been there in order for the Pluton K to cut through them. So this means that A is our oldest layer. I'm going to try and get some stuff out of here so we can see what we're doing better. So we're going to put A down here as the oldest layer. So then we're going to move forward in time to younger layers. The principle of superposition, which is what told us that the oldest layer needed to be on the bottom, is also the principle that helps us figure out what happened next. So remember that a layer on top of A is going to be the next youngest, and then the layer on top of that, so that's B, is going to be the next youngest, right? All of these things are superposition. We know from cross-cutting that the dikes, dike L and dike M here, are cutting across all these layers. So they've got to be younger, just like Pluton K was. So we can say then that the next layer would be layer B, right? It's sitting right on top of A. Then layer C, sitting right on top of B. Then layer D, which is sitting right on top of C. And then finally layer E, which is sitting right on top of D. We have to stop there because the dikes stop at this line. This is an unconformity, So anytime you have a heavy black sort of squiggly line like that, that is an unconformity. The other lines that are in here, these thinner lines between layers, are considered the contacts between layers. But the black squiggly line is an unconformity. And what we find is that the dikes, both dikes, this one and this one, stop at that particular level, so they don't cut through layer F. So what we know now is that after E, something happened. We see the unconformity, which means erosion happened, and we see these dikes. So again, let's do a little erasing so that we can take a closer look at just the dikes. So we have dike L down here, and we have dike M here. And notice that they don't just cut across the layers, these layers, but they also, this one anyway, dike M cuts across Pluton K right there. And then if we look, if we follow L up, so L continues up this way to the surface, but this is part of L as well. And notice that it does not cut across Pluton K. So that gives us some age relationships, which can help us figure out which happened first. So we're looking at L, K, and M to figure out which happened first. So we can see that K cuts across L right there, right? L doesn't cut K, K cuts across L. That means that K must be younger than L. L was already there when K happened. And then we have dike M over here, which cuts across K. So K was already there when M happened. So M has got to be younger than K. So this means that the earliest of these three things to happen was L. The second was K. And the third was M, right? Because L was already here, then K happened and cut across L, and then M happened and cut across K. Now at that point, what happened was the erosion, right? So we have the erosion happening. But after the erosion happened, we have some more layers deposited on top of that erosion surface. So we have F and G and H, which all are deposited on top of that erosion surface. We can use the principle of superposition to again tell us that H is younger than G, which is younger than F, right? We also have this fault here that we have to be concerned about. So again, let's clean the drawing up a little bit. Oops. So we can not end up confused by these other things. Got B back there and C back there. So the fault cuts through A, B, C, D, E, F, G, and H, right? It extends all the way up. As far as we can tell, it does not cut through the lava flow, which is I, but it does cut through everything else. So it must be younger than these layers here. So that tells us that after the erosion, after that unconformity, the next thing that happened was F, and then G, and then H. Then the fault J cut through everything. So that was the next thing that happened. And then finally, this lava flow was deposited on the surface as I. So now you have determined that the oldest layer, the oldest thing that happened, was the deposition of layer A, and the youngest thing that happened was the lava flow. And you've determined the order in which not only these different layers were deposited, but also when the dikes, the Pluton, and Dike L came into the picture, what they cut across, and how their age corresponds to the age of the layers. So I hope that this will help you figure out the cross sections in the lab. Really, this is kind of like a logic puzzle. Once you get started and you remember that you're using those principles, superposition and cross-cutting are the two that we used most prominently in this one. You will also be asked to identify unconformities. So we only had one unconformity here in this drawing, and this unconformity is between what looks like a sedimentary layer and another sedimentary layer, and the two are parallel to each other. And that would make that a disconformity. Now, if we were looking at this unconformity just in this area right here, we would have an igneous layer underneath here, which is crystalline, and then a sedimentary layer on top of it. And that would be considered a non-conformity. But we would consider this a disconformity first, because most of this unconformity that we're seeing all through here and all through here and all through here is actually sedimentary layers on the top and the bottom that are parallel to each other. There is no angular unconformity in here. Remember, an angular unconformity would be if we had sedimentary layers, we had an unconformity with sedimentary layers that were tilted on the bottom and parallel to each other, not parallel, horizontal layers that were not parallel to the lower ones on the bottom of the unconformity.